So by the way, if anybody has more questions, we'll be around during the hackathon tonight as well. So if you have any questions that you are not able to ask right now or you realize only later on, you can come down here.
I won't be at the hackathon, so it's better to ask me after this lecture.
Absolutely.
But you can also I'll also share my email in case you have any questions. All right, everyone. Hopefully you're in the right place. We're going to be discussing React Native today. My name is Simon Eisman. I am a mobile apps developer at Bloomberg. We work on a production application built entirely, almost entirely, in React Native. So today we're sort of going to do a little bit of a dive into React Native and how to get up and running, but more so to allow you all to see the power of React Native and how quickly it is to both prototype things, but also be able to make applications with them that are more production ready. So a little bit about what we're going to cover in this lecture. I'll introduce myself. We'll talk about a little bit about what React Native actually is. I'll make the case for it, but I'll also make the case against it. And then we're just going to touch on some very simple principles you need to understand. If you've worked with React before, we'll basically be touching on that primarily. But it'll be important for understanding how to build views, how to build components in React Native when we go into the next slide, or into the next part, which is the demo. After that, the demo will take up the majority of our time, but I'll also discuss some advanced usage, some things that you will probably want to do in your applications if you do use React Native, but definitely there's no time to cover it in this hour or so long lecture. I'll also talk about what we use at Bloomberg and how we've been able to make our workflow a lot faster and how we've been able to make building with React Native faster. And then I'll leave you with some links because everyone loves links to awesome things. And then there'll be time at the end to ask me any questions. All right? So first, a little bit about me. I already mentioned I work at Bloomberg. I was also a Hack and Why Fellow in the summer of 2015, where I interned at Foursquare. And I've been a mentor these past 2 summers in Hack and Why, hopefully this summer as well. I teach a data structures and algorithms course where I cover those topics and intermediate C++ at Hunter College in New York City. I've already been teaching there for 3 semesters, taught about over 100 students in those topics. But besides that, everyone loves tech, but there's life outside of tech. I've also been a dancer for a long time, been doing it for 18 years. It's been a while. And recently I picked up wushu, which is a kind of martial art, and I do improv at UCB. Haven't done it in a while. I'm on a little bit of a break, but that's okay. All right, so to the topic at hand. So what is React Native? So according to the documentation, open source, cross-platform way of building JavaScript applications, specifically on phones. Now, it was sort of born out of React, which is a way of building web applications. But clearly, the people at Facebook saw a need for this, a way of abstracting the ability to build applications on phones using the same sort of awesome paradigm of React, but on phones. The reason that this works, we're not even going to touch on how interesting and complicated this is, but at the very core, React Native utilizes the JavaScript core of iOS and Android, which allows you to write primarily most of your code in JavaScript, but it's able to communicate with native components on that platform. So both in iOS, both in Android, it hooks into the JavaScript core and you're able to build applications that way. It communicates via what's called a bridge in order to send JavaScript events to your React Native application and vice versa. But without getting into technicals about this is all really interesting. You can learn more about it on your own time. Let's sort of talk about why you might even want to use this. So it's multi-platform, and I say multi-platform, not just iOS and Android, because there are currently efforts to make this available also on Windows, and there's an experiment to do React Native or React in the web. There's a lot of interesting aspects of this. But essentially what it allows you to do is it allows you to share 80% of your code between your iOS and Android applications, which is kind of insane if you think about it. When you have two different sets of developers, iOS and Android, but using React Native, you can basically have it be one team that works primarily on a single JavaScript code base. More so, you can think of this as using native wrappings, meaning all of the components that you're using when you're using React Native are actually native components. Now, yes, there are some things that are only JavaScript, but at the core, a text component is a text component is a text component. It's very similar between iOS and Android, so you should be able to utilize that under the hood the same way. React Native is pretty young. It became published sometime in 2015. I think iOS was March, and Android was later that year. But even over these last few years, a very wonderful community has sort of formed around this. Because React Native is open source, there are a ton of open source tools that you can utilize in your own applications and sort of leverage and bootstrap yourself. One of the greatest examples of this is a boilerplate generator called Ignite, which you press a button, it literally sort of builds the application for you with navigation, with being able to leverage side effects in your application, with testing, with rendering ability. There's lots of things that you can do, and all of this was sort of around an open source community effort to make React Native more accessible by that company, Infinite Red. So, I went to a conference by them this past year, and I'll share a link to those talks. When I was there, it was very easy to see that there's an awesome community that's being built around React Native, even though it's so young. Now, those two things are great. You can build on multiple machines. There's lots of tools that are available. But when you have the nuts and bolts of it, you're developing faster. Something I like to tell people is that our team, after we switched to React Native, had twice as many developers moving twice as fast. We were able to speed up our time over the long term just because we had, 4 times the throughput, basically, in order to build our application. But day to day, we realized that the tool sets that are available both with React Native and by the open source community allowed us to just develop faster. You'll see that there's no need to actually, or there's less of a need to build your code. You can just simply reload it. As soon as you make a change, it's sort of instantly reflected on the screen, which is awesome when you see it happen, and you sort of breathe a sigh of relief and realize how fast it is to develop. Now, I won't really get into these last two too much, but you're using the power of React as a way of declaratively saying what your component will look like given such and such input. So we're not going to talk about the benefits of functional programming, let's say over imperative programming, but suffice it to say, it becomes a lot easier to reason about how you're building your applications. And of course, there's lots of great debugging tools. You'll see one of which you'll see during our demo. So there are still some things about it that maybe might push you away. Technically, it's still an ODOT release, so it's still technically in beta. It's still powerful, don't get me wrong, but technically it's still in beta. So there are definitely some kinks that are still being worked out. There's still lots of features that people have requested. But that's, it's still something to consider if you choose to build with it. Sometimes JavaScript isn't enough. Sometimes you need to hook into the native functionality. Sometimes, let's say you need something related to force touch, maybe. Or maybe you need something related to something that Android does specifically with intents, right? Therefore, native code requires native knowledge. You need to be able to, if necessary, go into the native aspects of the code. And sometimes it will be necessary. So you'll have to sort of learn iOS and Android development as you go. When I started, I was a native iOS developer, but now I'm sort of an Android developer too-ish, because I have to look at the Android code when necessary. Now I put JavaScript up here as a con, and that's not like a dig at JavaScript. It could have also been a pro. But I think in this case, when I mention it, it's sort of around JavaScript and its ecosystem, which means JavaScript is good, it's okay, but you need a lot of tools to make it sometimes work better. One way that this sort of comes out most prominently is with typing your code. So it's not really a typed language, so you can't immediately see what the type of a variable is. So you may have to like add something on top of it. You can use something called flow, which is what our team uses, or maybe something like TypeScript, which allows you to type your code that way. But sort of in this case, I sort of pointed out as a con because it may make your code a little bit more brittle, especially depending on your use case. At this point, it's sort of related to the beta aspects of it, but there are some platform divergences, so you may have to check things on iOS and Android. And we're actually going to see a good example of that today when we're going to be doing our demo, where something might appear one way in iOS, might appear a different way in Android, and you have to check, and you have to read the documentation, because the documentation is pretty good about explaining some of the differences and what extra things you might need to do in order to accommodate them. So we're going to touch on some things very, very briefly, specifically around components, and not very much around styling, but just as a sort of like starter for us to understand. The main critical thing for those of you who haven't worked with React need to understand is the hierarchy of components. It's very much like HTML. You have components within components within components. And the way that those components know how to render themselves, the way that they know how they themselves are supposed to show up on your screen is via props and state. And it's important to understand the distinction between the two. State is data that is internal to a component. So only that component cares about that data. So when we were talking about the state of a component, it's more so information that that component knows about itself. And we'll see a very good example of that in a bit. Props, however, refer to data that's passed from the containing component, from the parent of that component. So it's being passed down to the component inside of it, and we'll see a good example of that too. Sometimes you need to know when these components actually show up on the screen, when they're being updated on the screen, when they're being unmounted from the view hierarchy. So we may need to hook into the life cycle of those components. And lastly, we just need to understand that the way you style components in React Native is very CSS-like, and the sort of flexible support that you might need is supported through Flexbox. I'm not going to go into that today. Flexbox is a whole topic on its own, but that'll give you a good starter if ever you need to sort of understand how some of the code, why some of the code looks the way it does. So I'm just going to briefly show how you might create your styles. You basically create a style sheet like so, and you specify the different classes, if you will. I don't really want to overload that term, but the different ways that you can sort of style different components that are being rendered on the screen. So you can just reference them like styles.container, styles.headerView, and they will style that component accordingly. So let's actually take a look. So this might look a little bit foreign to you if you're not used to it, but let's sort of break this down piece by piece. The way that you write a custom component is by composing other components that already exist. You have things like views, you have things like text, you have things like images. There are lots of them available. But what you're effectively doing is you're composing them in an HTML-like manner. So we created this custom component called awesome component. The one function it sort of needs is tell me how to render myself. Tell me how to show myself on the screen. And the way that I explain that it needs to be shown on the screen is I have this top-level view. It's styled with this container style that I created. I have this image component. I say where it comes from. I specify a style on it. And then it has some other components of type text that are inside of it. So it's very hierarchical in that way. But at the core, all it needs to know is, in its simplest case, how does my custom component know to render itself. In its simplest case, it's like this. Sometimes a component needs to know certain information about itself, its internal state. And one very classic example of that is if the component is loading something, it needs to show one thing, but once it has data, it needs to show another thing. So at the very core, we might do it like so. In the constructor, we declare the state of this component. This dot state. And we say that to begin with, it's not loading, it's false. But if you ever call the fetch data, which is a function I wrote, that's not something the component knows about, it's a custom function I've written into this component class. Whenever you call this dot fetch data, I also want you to set the state, specifically the isLoading flag, to true. When I start fetching something, isLoading is true. Once that fetch request completes, I want to set the isLoading flag to false. That's a very simple example of how a component might only need to know about this itself, right? No one else cares about it, only that component does. And in the render function, which of course we need, we can get the isLoading flag from the state, and depending on what it is, we render one piece of text or another piece of text. Now, to clarify, I just want to mention about the first line in the render method. If you haven't seen that before, that's called destructuring in JavaScript. Basically what it allows you to do is it allows you to pick a key from an object, and you can just use it like a normal variable. So instead of doing this.state.isLoading all the time, or creating a separate variable, this is some syntactic sugar in order to get that key from the object. Props, like I said before, is data that's passed from your parent to the component. It's data that the component needs to know from up above. And there are lots of use cases for this, and you might ask, well, wait a minute, when do I use props, when do I use state? And we can only cover so much of that in this lecture. But let's say for now that these are our two separate indications of how data can be used to render different things in a component. What you need to specify first are prop types. Basically, you're saying, this is what I can accept. In this case, I've specified two props that this component can accept. Data, which is a required, as you can see at the end, where it says .isRequired, is a required property, which means that whoever uses me as a component, much like I have components being used here, these are how the props are being passed. There's a source prop being provided to the image. There's a style prop being passed to the image. This is how you specify properties on your component. So you would do the same thing. So for my awesome component, if I wanted to specify a prop, the closed universe of what can be provided, data is one of them. It's an array of numbers, I've said. And then there's another one that's not necessarily required called should show data. You don't have to specify it. Now, if you don't have to specify it, it's really good practice to supply a default for it. So prop types and default props are known to a component in React Native. So when you declare them, you're just sort of filling in the gaps. And much like we saw with state, in the render method, based on what the props are, you can render one thing or another. So already we're sort of starting to see the benefits of this functional style, where your output is almost entirely based on your input. Input in this case being your props, in this case being your state, and usually some combination of both, depending on the component.
Yeah, I have one question.
Sure.
Go back to, this is one, you have prop type static, means that you are defining what is static. But in the definition of data should that show you are using, that doesn't work.
Sure, so that's because those are properties of, so in this case, we're inheriting from the component class, which is provided by React Native. These are sort of known properties of the component class itself, and you're overriding it, or sort of. And the last thing I wanted to mention on this point is the lifecycle. There are a wonderful series of lifecycle methods, some of which are actually being phased out in React 17, but let's not get into that, that allow you to hook into various aspects of when certain things happen. So we have componented mount, which is when the component actually gets placed into the view hierarchy. Component will receive props, which is when the properties are updated from up above. That's something you'd want to know. And then based on that, you can do various things, such as fetching data. Let's say one thing you definitely want to do is whenever the component gets mounted into the view hierarchy, whenever it becomes visible, you want it to get some data about itself, right? It needs to know how to render itself. And to do that, it needs to get data from the internet. So that's a lifecycle hook you might want to use. Maybe when certain properties are changed, you also want to do that. Anyway, so we sort of covered the basic principles that I just wanted to touch on that we're sort of about to build together. So does anyone have any questions about the lifecycle, state, props, style sheets that I can answer for you? Yes?
Sure. Can you just go back to the props?
Sure.
So over there, is the fact that it should be showing data more a sense of state, or like that is one thing that, or is it strictly like something that's being passed down from a parent, and that's the distinction between props and state?
So this is an excellent question that relates to something called, like a paradigm called smart and dumb components, which I will not really touch on in this lecture. But usually a dumb component likes to be told exactly what to do. And for our purposes, let's say we want this to be a dumb component. Dumb component because we're telling it exactly everything it needs to know. We're telling it about the data, we're telling it whether it should show itself, there might be other information. So that's actually kind of, it sort of depends. It might be a personal decision about how loaded, no pun intended, you want your component to be. If you write everything in one component, everything, your entire application, do not do that, then you're going to have a lot of state, right? But if you want to break stuff out, usually that means you start specifying props on your children, and then you pass maybe state information of one parent component down to your child. So defining where that boundary is a little bit more of an art. You actually just need to reason about where is that data coming from, and how split out are my components. Any other questions? Great. So let's move on to our demo. Now, in order to sort of get started on this, we all know how finicky demos can be, especially if you're doing everything on the fly. So this is sort of like a controlled demo. In this case, I'll be sort of writing code, but then I'm just gonna check out another commit on my in my Git history. So I encourage you to do the same, because all this code was written over the course of maybe like 6-7 hours. So we don't have 6-7 hours, and you're not going to write this code with me. So we'll sort of go about this in a little bit of a controlled way. So if you want to start, I mentioned this before, you probably don't have time to do this now, but these are sort of the installation requirements that you'll need just to kind of try stuff out. At the very least, download the Expo app and have some version of npm yarn installed. You don't necessarily need create React Native app. Okay, so I thought to myself, okay, so I'm going to be giving a talk about React Native at MIT. I may as well make it somehow relevant to the people that go to this school. And what does everybody love? Well, that's a very big question. But for the most part, people like GIFs. Now, we're not going to have this GIFs, GIFs debate, it's not the place for it, but I figured GIFs, MIT, what's a great thing that gives us GIFs? Giphy, MITiffy is a terrible name for this, but it's the best I could do under the circumstances. So if you want to start up, basically just go to this GitHub repo and clone the MITiffy application. Just the sort of set of steps you can do this. If you want to try out creating an app, you can follow the instructions above, but what we'll be going through is this GitHub repo down here. So basically just clone it and get yourself started up with the server. That's what happens when you do yarn start. So I'll just give you maybe a minute, 2 minutes to do this. Also, just to clarify, yarn is just can be used instead of npm. So if you have npm, do that. But yarn is better and faster.
How can we install yarn?
You can just use npm if you have that. So just do npm install, npm start. So we're going to be doing this in stages, meaning we're going to start at stage 0, and we're going to work our way all the way up until stage 10 in various degrees of speed. So at every point when I say that we're moving on to the next stage, what I really mean is you have to do git checkout stage 1, git checkout stage 2. Okay, after you get to this, and you start your server up, in the Expo app, when you start your server up, you'll see a QR code. You can then go to your Expo app, scan that QR code, and then see the app appear before your eyes. Now, don't forget to check out stage 0, because if you do it from the current state of master, it's going to be too awesome to behold. So do it when it's not so awesome to behold, which is the very beginning. So what are we going to do today? Today, we're going to build a very simple GIF listing application. Our goal is to basically make this show MIT-related GIFs. So we're going to use the Giphy API to get all that information and interestingly render that on the screen. Okay? That's going to be our end goal of this demo. So just raise your hand if you've tried this out and you sort of see something on your phone screens. If not, it doesn't matter as much because we're sort of brought to this stage already. To begin with, if you wanted to create an app on your own, you would just do create React Native app, test app. It starts building. At the end of the day, it'll probably look something like this, where it makes the project, and at the end of the day, it gives you some really helpful instructions. It installs some dependencies that you need. That's why we did that yarn install. And then it gives you some really good instructions on what you want to do in order to get yourself up and running. So what I've done on my machine right now is I've downloaded MITiffy, awful name. I've downloaded MITiffy, I went into the directory, I've installed all the dependencies, and I've checked out our starting stage. And what I've done on my machine here that you can't quite see is I've started up my server. So what does this actually mean? What we're doing here is that we basically have all the local JavaScript code that we need. And what we do is we build a bundle of that JavaScript code that is then being served out to whoever is listening. in this case, to our local machine. Now, in order for you to maybe even, for me to use this, I need to be on the same network. So whatever machine is serving the JavaScript bundle, the same network is going to accept my app. So that's what you should see. It's kind of not really much. It's just a bunch of text in the middle of the screen. But let's change it. Now if I change it, it reloads instantly. Now that's cool. What was written there wasn't cool, but that's cool. Now for those of you that have ever worked with iOS or Android, you would have to stop the app, rerun it, wait the minute, hopefully like it's a couple of seconds, and then you have to get to that part in your application. If it's a big app, this could take minutes of your time just to rebuild the application. But we already see that it happened instantly. You change your code and it's instantly visible. What's also instantly visible is any errors that you have. So if I did something wrong, oh, it's going to tell me. Oh, you best believe it's going to tell me. And it's going to be your task to figure out what the error is, and that's something, of course, that comes with time. But this gives us a glimpse into how fast you can develop with this. All right, so let's maybe move a little bit forward on this. So let's kind of see the stages at which we'll progress. So when we go from stage 0 to stage 1, we just added that extra line. So if you do git checkout stage 1, you'll see that we just added another line to our demo app. Great. Then what we're going to do is we're going to make a simple component. I'm just going to call it home feed. It's very simple, and to start, it's going to have literally almost nothing in it. It's just going to be a square on the screen that I want you to be able to see. And then I want this basic ability to just add a bunch of these squares onto the screen. So the home feed will be replaced with a listing of what will ultimately represent GIFs. So let's try that out.